Hello guys, today I'll be explaining the Math CA for Term 3 Week 3. Okay, so for this first question they're asking what is true. Okay, so AF is a chord is the first one. Okay, so a chord is basically just a segment, a line segment. It's a line segment like that joins 2 points on the circle. So you have to be on the circle for so this is the circle. It's clear, like you all know that this is a circle, and A is not on the circle, and they're joining it with F. So this is not going to be a chord because A is not on the circle. A chord is like a line segment joining 2 points on the circle. So let's say like CF would be a chord, for example. Okay, FC is a diameter. Okay, so a diameter is also a line segment. Also a line segment that is joining also 2 points on the circle, but this time it has to go through the center. And FC is joining 2 points on the circle, and it goes through the center, which is O. So this is correct. FC is a diameter. We got BC is a chord. Yeah, so as I said, a chord is a line segment joining 2 points on the circle. B is on the circle, C is on the circle, and they're getting joined, so that is a chord. DE is a diameter. Yeah, okay, so D is on the circle, E is on the circle. They're getting joined, and it's going through the center, which is O, so that is going to be a diameter. OE is a chord. No, okay, so OE is not a chord because O is not on the circle. It is the center of the circle. So this would be a radius, not a chord. And then we got BC is a diameter. BC is not a diameter because although it is joining 2 points on the circle, it is not going through the center. Okay, which of the following is true? A is in the exterior of circle C2. Okay, I think you all know what exterior and interior means. Interior means inside, exterior means outside. Okay, so A is in the exterior of circle C2. So this is circle C2. And here. Okay, A is in the exterior. No, A is in the interior, because as you can see, it's inside circle C2. So this is wrong. F is in the exterior of circle C1. Okay, so this is circle C1. They labeled it. F is outside, so that means it's on the exterior. That is correct. D is in the interior of circle C2. That is circle C2. And D is inside, which means it's in the interior. F is in the exterior of circle C2. Exterior? No, it's actually in the interior because it's inside. So that's wrong. A is in the exterior of circle C1. Yeah, A is in the exterior. And then D is in the interior of circle C1. Yeah, no, it's on the outside of circle C1, which is the exterior. Okay, so for these algebraic, this is algebra. So this is the nth root. The nth root. So first of all, you have to look at the index. This little number, kind of on the outside of the radical, but it's on the top. Okay, so what this basically means is that whatever that number is, the number the numbers and the variables inside the radical have to be to the power of that number for them to be able to go outside. So let me give you an example. X to the power of 7. When you take it outside, it will be x. Because 7. So when you take it outside, it's just going to be x. Okay, so back to this question. So first of all, we have to prime factorize. So 64, 32 and 2, 16 and 2. Okay, so we have 2 squared, 2 to the power of 4, 2 to the power of 6. Okay, and then for the variables it's very easy to set them up. We have 2 to the power of 6, and as we said, like, to make this easier you have to label it like, try to put them in order of powers of 7. So I have x to the power of 7, and then let's leave what's left, which is 7 plus 11 minus 7, which is going to be 4, x to the power of 4, and then we have y to the power of 5. We can't change it because it's not going to go outside since it's not in the power of 7. Okay, so we have 2 to the power of 6 cannot go outside because it's less than 7. X can go outside. This can, x to the power of 4 cannot, and y to the power of 5 cannot. So it's just going to be 2 to the power of 6 is 64, as we said in the question. 64, and then x to the power of 4, y to the power of 5. That's going to be your final answer. Because you cannot take x to the power of 4 or y to the power of 5 outside, because they're less than 7. And you cannot take 2 to the power of 6 outside, because it's also less than 7. So, it's going to be x, yeah, as we said. Now, this is just basically the same thing, but they put a different index. So now it's to the power of 8. We already prime factorized 64, so I'm just going to move on from that. It was 2 to the power of 6. And then x to the power of 14. Let's put that in powers of 8. So it's going to be x to the power of 8. And the 14 minus 8 is going to be 6. So x to the power of 6. We take out x to the power of 8. It's going to be x. X to the power of 6 cannot be taken out, nor can 2 to the power of 6, since they're both smaller than 8. And then also, this is not our final answer. We have to see if we can, for this part, we might be able to put absolute value. So, how absolute value works, if an even exponent, like this is inside the radical, if it's even inside the radical, and then turns odd when you take it out, you apply absolute value. And then if it's like of course even and even you don't put absolute value. Odd and odd you also don't put absolute value, and nor do you do that for odd to even. So only if it's even inside the radical and we take it out it's odd, that's when you apply absolute value. So let's go back to our answer, x 64, x to the power of 6. Okay, so it was x to the power of 14 when it was inside the radical. When you took it out it became x, so it's obviously going to need absolute value. So this is going to be your final answer, because it went from even to odd. X to the power of 1, it went from x to the power of 14 to x to the power of 1. Alright, for this part, first of all we're going to need to rationalize the denominator. So we multiply by C4 up and down. Radical C4 actually, up and down. Wait, no we don't. No we do. My bad. No. Not C4. Okay. So they said, so the index is 6. So as we know, it has to be to the power of 6 for us to take it outside. So since it's already c to the power of 4, all we need to do is multiply by c to the power of 2. Up and down, of course. So then this becomes c to the power of 6 and we take it outside. Okay. So this will be 128 B11 C2 over 6th root of C6. Okay, so We'll take it out and it will just be c. And then it went from even, which is to the power of 6, to odd. So we apply absolute value. Now, 128, we'll need to prime factorize that. 128 is first of all we have 2, of course, and 64, 32 and 2, 16 and 2, 8 and 2, 4 and 2, and then 2 and 2. So we have 2 squared, 2 to the power of 4, 2 to the power of 6, 2 to the power of 7. Okay, so I have 2 to the power of 7. B to the power of 11, that's just going to be... Wait, no, let's do that in powers of 6. So we have 2 to the power of 6 multiplied by 2. This just makes it a lot easier. B to the power of 11 is going to be B to the power of 6 multiplied by B to the power of 5. And then as we said, since we multiplied by C2, we also have C2. So this cannot be taken out, this cannot be taken out, and this cannot be taken out. What we could take out is 2 and B. B went from... it went from... No, it didn't actually. No. So, we'll take out 2B. And now, it was B to the power of 11 when it was inside the radical. When we took it out, it became just B. So it went from 11, which is odd, to 1, which is also odd. So we don't apply absolute value here. So your final answer is going to be 2B. And then the 6th root of 2B5 C2. Oh wait, I forgot the absolute value C in the bottom. That's gonna be your answer. Yeah, don't change anything. I just forgot it. Wait, did I pick the right answer? Yeah. Okay. Now, so for this one, first of all, let's see what we could simplify. Let's start to prime factorize. 5 is already a prime number, so we just leave it. Then, as I said, we have to put them in like powers of 5. So we have x to the power of 27 is x to the power of 5 multiplied by x to the power of 5 multiplied by x to the power of 5, and so on. I don't have space. So yeah, this stays. This is x squared, x cubed, x to the power of 4. So we have x to the power of 4 over here. No, x to the power of 5. Why did I forget the last one? It's not x to the power of 4. And then we have y to the power of 4 that cannot be taken out. It stays because it's less than 5. So, when you have no, wait. No, not about that. Okay, so it was odd, and then when you took it out, it's x to the power of 5, it stayed odd. So again, you just don't apply absolute value. You only apply absolute value when it went from even to odd. So your final answer is going to be x squared y4. So x to the power of 5, then the 5th root of 5x squared y4. Okay. Now, x must be non-negative for the expression to be defined. Well, that's wrong, because when you have an odd index, which is the number over here, as we all know, you don't need a negative, you don't need a non-negative number inside the radical over here. Like, it's fine if this is negative, because, like, let's say you had, this is odd, and then negative 1000, which is just going to be negative 10 multiplied by negative 10 multiplied by negative 10. That equals negative 1000. So, again, it does, like, if it's an odd index, it doesn't matter if the number inside the radical is negative. Like, there is a solution to that. So no, x doesn't have to be non-negative. The expression is defined for all real values of y. That is true because, first of all, y cannot be negative anyway, and then even if it was negative, it won't matter, because it's an even exponent, so it won't matter. Yeah, look. Okay, so for this one, again, the first thing we always do is prime factorize. 256 is gonna be 128 and 2. And then you could do the, I'm pretty sure it's just 2 to the power of 7. Yeah, it is, because we did that the last question before this. So you could do the long way, you'll still get the same answer, but this is just 2 to the power of 7. So we basically have 2 to the power of 8. Okay, so 2 to the power of 8 is 2 to the power of 4 multiplied by 2 to the power of 4. Since we have to put it in powers of 4 to make this like easier. U to the power of 6 is u to the power of 4 multiplied by u squared. And then w to the power of 5 is w to the power of 4 multiplied by w. This stays. This also stays. You take this out, it's going to be u. You take this out, it's going to be w. And then you take a 2 and you take another 2. It's going to be 4, because 2 multiplied by 2 is 4. So you'll have 4uw u squared, and then we can't forget the w. Okay, so it was u to the power of 6, and then it became odd. It went from even to odd, so we apply absolute value. But for w over here, it was odd, and then it stayed odd, so we don't apply absolute value. So your final answer is going to be 4 absolute value u w, and then the fourth root of u squared w. Okay, so that's the correct answer. And then the expression is defined for all real values of u. Let's see. So since it's an even index, it has to be non-negative. Like, it's same thing with radicals. Like, you can't have a radical negative 16, because like, as we all know, radical is just like the index would be 2 if it was a radical. So this is the same thing. The index is 4, it is even. So if u was negative, like the solution, there would be no solution. But here, u is to the power of 6. So even if u was, let's say, negative 1, negative 1 to the power of 6 is just going to be 1. So, yeah, the expression is defined for all real values of u. Because even if it was negative, it would be positive in the end. Okay. W must be non-negative for the expression to be defined. Let's see. So, W is odd, because it's to the power of 5. And as we know, when we have an odd exponent, it can't, like, you can't have a negative, like, let's say negative 1 to the power of 5 would be negative 1. And then we can't have a radical, like a fourth root of a negative number, Just like how you can't have a radical of a negative number. So, for the expression to be defined, w would have to be non-negative. Because you cannot have the, if you had an even index, you can't have the number inside the radical be negative, or else you won't have an answer. There would be no solution. Okay, which of the following statements is true? So negative 4 is the principal sixth root of negative 4096. Okay, so as I explained in this last question, when it's an even index, you can't have a negative number inside. There would be no solution. So this is wrong. There's no solution, and it's not negative 4. Negative 4096 has two sixth roots. This is literally just the same thing. As I said, when there's an even index, there's no solution. It has no roots. 4 is the fourth root of 256. Let's try that. 4 to the power of 4. So 4 multiplied by 4, which is 16. 16 multiplied by 4 is 64. 64 multiplied by 4 is 256. So that's correct. 4 is the principal sixth root of 4096. 4 is the principal sixth root. Okay, let's see. So we'll do the same thing, but we'll just continue on. So 256, then we multiply by 4. 20, 22, 8, 10. And then we multiply by 1 final 4. 16, 8, 9, 0, 4. Yeah, so it is the sixth root. Okay, and then we have the fourth root of 246 is equal to 4. This is basically this is basically the exact same thing as we said in 4 is a fourth root of 256. The same exact thing, so this is also correct. And then negative 4 is a fourth root of 256. Okay, so when you have an even index, you're gonna have two solutions, and the number inside, of course, it has to be positive. You're always gonna have two solutions. This is also the same thing in radicals. Let's say it was, since as I said, radicals are just index 2. It's even. So radical 16, it's not actually radical 16. I can't say that. I have to say root of 16. Just like how it's going to be root of 256. So this is basically fourth root of 256. I can't say radical. Forget the radical. As we said, radical 16, both roots of 16 is negative 4 and 4. And same thing here, since it's even, the index is even, it's gonna be correct. So it's gonna be negative 4 and 4. It's not just gonna be one number, but that's only if the index is an even number. As we said, it's correct too. If you had an odd index, there want to be two solutions. Okay, given the points A, which coordinates is 1, 5, and B, 3, 21, the coordinates of the midpoint. Okay, so this is really easy. I'm sure you all are familiar with the midpoint theorem. So first of all, the first given point is going to be always x1 and y1, and then the second is going to be x2, y2. That's for the coordinates. And the midpoint theorem is x1 plus x2 over 2, comma, y1 plus y2 over 2. This is to find the coordinates of the midpoint. So we have x1, which is 1, plus 5, it's going to be 6. So this is 6 over 2, which is just 3. Okay. And they want the value of A, so we don't really have to find B. But let's just do it either way. We have y1, which is 5, y2, which is 21. 21 plus 5 is going to be 26. And then over 2, which is 13. So B is 13 and A is 3. But in the question they only wanted A. Okay, what is the distance? When they say distance, that means you use the distance formula. And the distance formula is all in a radical, first of all. x2 minus x1 squared plus y2 minus y1 squared. So we have x2, which is 1, minus x1, which is 4. So we have 1 minus 4. It's going to be minus 3. When you square it, it's going to be 9. We have y2 minus y1. y2 is 2 minus y1, which is 6. 2 minus 6 is going to be minus 4. And when you square it, it's going to be 16. So 9 plus 16. That's 25. Wait, no. Yeah, so we have 25. Because as we said, 9 plus 16 is 25. Radical 25, easily 5. We all know that. Best also, make sure you don't make this common mistake. I always see people making it. They do, once they get 9, and then, like, let's say we had 16, they do radical 9 plus radical 16, which is just going to be 3 plus 4. And they say it's 7. That's wrong. You're not supposed to do that. You can only do that if it was multiplication, not addition. So as I said, the answer is going to be 5. Always make sure to join both numbers together, then you do the radical. Okay, again, keyword on distance, the distance between the points. That's all you need to know, and then you immediately know what you're doing. So, again, when I said you see distance, you do the distance formula. We have x2, which is 7, minus x1, which is minus 2. So minus 2 is going to be keep, change, opposite. So it's going to be 9 squared, which is 81. Let's write that later. Let's write that up top over here. And then plus y2, which is minus 4, minus y1, which is also minus 4. Keep, change, opposite. Minus 4 plus 4 is 0. So 81 plus 0 is just going to be 81. And the radical of 81 is 9. So your answer is 9. Okay. So I've heard all of you guys start complaining about this question because you say it's not like we didn't learn this. I'm pretty sure it's just a grid. A group of friends collectively participated in 2 games, Game A and Game B. In the scatter diagram, each dot represents a member in the group and shows the scores that person got in the 2 games. Okay, so everyone here played 2 games. And this just says like who the points they got, these little dots. Like their scores. The range of the scores in Game A. Okay, so when they say Game A, we only look at the x-axis. Forget the y-axis. Okay, the range is basically the highest number, like the greatest number, subtracted by the lowest number. So we have 50 as the greatest number. Minus the lowest number. In Game A, it is 10. Which is 50 minus 10, which is just 40. Carl is the student with the highest score on Game A. His score on Game B. Okay. So, the highest score on Game A is 50. And they're asking for his score on Game B. So, like, let's connect them. And so, this is 5, 10, 15, 20, 25, 30, 35, 40, and this is going to be 45. So, he got 45 on Game B. The highest score on Game A is blank than the highest score on Game B. Okay, so 50 is the highest score on Game A. And then Carl got the highest scores in both games. which is going to be 45. So the score on game A is great. The high score on game A is greater than the high score on game B. Because 50 is greater than 45. The diagram shows a blank correlation between the scores on game A and game B. Okay, so this is positive and negative correlation. So basically what positive and negative correlation means, if it like increases like this, it's positive correlation. If it were negative, the correlation would be like this, which is not happening in this case, because as you can see, it's increasing. So it's positive correlation. The biggest difference between the scores on the two games of a member in the group is blank than 5. Okay, so first of all, Carl got 50 and then he got 45. That's 50 minus 45 is 5. Then 40, okay, all of these. Okay, so this guy got 40 in the second game, so he has 0. 35 and 40, that's also 5. They have 30 and 40. So that is greater than 5. Because 40 minus 30 is 10. So the biggest difference is greater than 5. Okay, Kate, Mary, and Angela participated in a 12-kilometer run. The graph drawn below shows what happened during the 12-kilometer run. The lines show the distance of each athlete from the starting point at different times during the run. Okay. So they're asking who won the race and how much did it take her to finish the run. Okay, so let's see. So we all know that like to win the race you have to do it in the shortest time. And let's see, where are they? Okay, so they're plotting the time on the x-axis. So the lowest on the x-axis, like the shortest, is obviously Kate. So Kate won the race because it took her 40 minutes. While the others so that's why Kate won the race. Okay, so Kate won the race. It took her 40 minutes, as we said. And now, Kate overtook Angela blank minutes after the start of the run. Okay, so overtake basically just means like the moment that she was faster than her. So we have Angela as the red line and Kate as the green line. Okay, so the moment that we could see that Kate overtook her was when so here she was losing and then now she's winning. So it is 30 minutes. So she overtook her at Angela 30 minutes after the start of the run. Okay, the coordinates of the midpoint. That's all you need to know. Midpoint. Midpoint formula, the midpoint theorem, is x1, as I said. I don't think I have to say this again, but I'll just do it because why not? y1 plus y2 over 2. You all should know this. Okay, so x1 is negative 5 plus x2, which is 17. That's going to be, then we over 2, that's going to be 12 over 2, which is 6. So x is 6 over here for the midpoint. And then we have y1 plus y2, negative 2 plus, no, not negative 2, you just have 2, plus negative 3, which is negative 1 over 2. Okay, so y is negative 1 over 2, x is 6. Okay, distance, again, immediately you know what you're doing. So we have x2, 1 minus 5, that's going to be 6. Then 6 squared is going to be 36. So first of all we have 36 up top. Let's put that. Then we have y2 minus y1. Keep change opposite. That's going to be negative 9. Negative 9 squared is going to be 81. The distance formula is just x2 minus x1 squared. plus y2 minus y1 squared, all in a radical. So I have 36 plus 81 in a radical now. So that's going to be 6 plus 1 is 7, 30 plus 80 is 110. So we have 117, so we have radical 117. Again, make sure to add, then you do the radical. So now we need to prime factorize. 117 is 3, then 39, 13 and 3. So since we have 3 squared multiplied by 13, wait. Yeah. We take out this 3, and it will be, we take out this 3 squared, it will be 3 radical 13. Okay. So 3 radical 13. Distance. Again. Like, first 2 words and you already know what formula you should be using. It's that simple. Okay, so x2 minus x1. We have 7 minus 2. That's going to be 9. 9 squared is going to be 81. Then we have y2, which is 8, minus 4. Because y2 minus y1. That's going to be 12. Squared, it's going to be 144. So I have 144 plus 81. That's going to be 1 plus 4 is 5. Then 140 plus 80 is going to be 225. So radical 225, which is just going to be 15. So the distance between the points A and B is 15. Now the distance between the origin, keyword origin, and point C, which is negative 8, 15. So origin, as we all know, we learned this like in last year, the origin is always 0, 0. Because it's the first, the first thing on the line is always going to be 0. So x0, y0. The origin, negative 8. The distance between the origin and point C, which is negative 8 and 15. So origin is always going to be since it's the first on the line, we're going to address it as x1 and y1. So we have x2, which is minus 8, minus 0. That's just going to be negative 8 squared, which is 64. And then we have 15 minus 0, 15 squared, which is 225. So I have 64 plus 225, it's going to be 289. So I have radical 289, which is 17. Okay, consider a segment whose endpoints are S, negative 413, and T, 8, negative 5. Given the midpoint, that M is the midpoint of the segment. Okay, so midpoint theorem. x1 plus x2, which is 8, minus 4 plus 8, it's going to be 4. Then we have 4 divided by 2, of course, it's going to be 2. Because we did minus 4 plus 8, 4 divided by 2, 2. Okay, so 13 plus minus 5, it's going to be 8. And then over 2, it's going to be 4. So x is 2 and y is 4. That's the coordinates of the midpoint. The distance between points M and S is 3 radical k. Then k equals, okay. So, I'm pretty sure here S is x1, y1, because M is like the midpoint. The midpoint's in the middle of the line. And S is gonna be first, because S, then T. This is how it's gonna be, because this is the midpoint. Here, this is the end point. Okay, so S is x1 and y1. Okay, so distance. So we have x2, which is 2, minus 4, 6 squared, which is 36. And then we have y2 minus y1. Minus 9 squared, which is just going to be 81. Okay, so 36 plus 81 is going to be 97. And no, 36 plus 81 is 117, my bad. Always remember the distance for formula is x2 minus x1, because I'm feeling like maybe some of you guys just like don't know what I'm doing. y2 minus y1 squared, and then all of it in a radical. And no, you can't just cancel out the squares like this. Okay, so we have radical 117. And this is literally just the same thing we got from the other question. Yeah, 3 radical 13. This is the same thing we did, because it's also asking for radical 117. So k is going to be 13. Now here. Okay. So index is 3, so we're going to need the numbers in powers of 3. So I have 108. That's going to be... fine, let's do 2. 2 and 54. 54 is 9 and 6. Or it's just going to be, to make it easier, 2 and 27. Then that's 9 and 3. And then that's 3 and 3. So I have 3 cubed and then 2 squared. Okay. And then x to the power of 13 in powers of 3 is going to be x to the power of 3, 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 multiplied by x. X stays the same, let's just leave it inside the radical. And then we have y to the power of 11 is going to be y to the power of 3 multiplied by y to the power of 3 multiplied by y to the power of 3 multiplied by y squared. So we take out y squared, y cubed, x squared, x cubed, x to the power of 4, y squared, and then we have 3 cubed, it's going to be 3, and then we leave in the 2. So you have 3x to the power of 4, y squared, and we can't forget the 3 up here. No, not y. Why did I say y squared? It's actually y cubed. I literally just messed up. I don't know why I wrote y squared. But look, y squared, y cubed. Okay, so we have 3 multiplied by x to the power of 4, y cubed, to the power of 3, and then we have 4xy squared. I just miswrote that. Okay, so 128 is, again, we did that in the previous question. It's just 2 to the power of 7. We did it in like 3 questions. X to the power of 28 is multiplied by x to the power of 7, multiplied by x to the power of 7, multiplied by x to the power of 7, multiplied by x to the power of 7. And then y to the power of 9 is y to the power of 7 multiplied by y squared. And then we have y to the power of z to the power of 21. It's going to be z to the power of 7 multiplied by z to the power of 7 multiplied by z to the power of 7. So the only thing not in the power of 7 is y squared over here. So we are going to have 2 to the power of 7 becomes 2. X squared, x cubed, x to the power of 4. We have y to the power of 7, just y. They have z to the power of 7 which is z squared, z cubed. Then we leave in the y squared. So we have 2x4, and then they filled out the rest. Oh, and we got something wrong. Let's see. Given the points a 1 5 and b 3 21, what is the value of a? Okay, so I have x1 plus x2 4. Why did I say 3? It's actually 2. I don't know why I said 3. Yeah, okay. So I don't know why I said 3, but anyways, good luck on your exam. I hope you all understood. I hope all of you guys do well as well. Good luck.